Hello grade 10 students, or maybe even grade 11 or grade 12 students who are revising. In this video, we will be going over stoichiometry, or the quantitative aspects of chemical change, and I'll be doing a class test with you. Now, I'm calling it a class test, but these questions are based on past paper questions. I took them from past paper exams, so this is exam level stuff. It would be awesome if you did the test with me, so I'll link it in the description box below along with other useful videos and my stoichiometry study guide in case you want to check that out. Do the test with me, then unpause me, watch how I do the answers and mark as you go along. My first question says calculate the following. Concentration of a solution of 300 cubic centimeters water, 15 grams of NaOH. Now my first hint to you, or my first piece of advice, is to list your variables. So I'm looking for concentration. The 300 cubic centimeters, that is volume. You need to know that cubic centimeters represents a unit for volume, and you need to know that it cannot be in cubic centimeters, it must be in cubic decimeters. How do you get from cubic centimeters to cubic decimeters? You divide by 1,000. So we've got 0,3 cubic decimeters, that's my volume. And then this 15 grams is my mass. It's baby M, mass. 15 grams. And they give me this compound, NaOH. That NaOH I can use to work out my molar mass. As soon as you know your compound, you can work out molar mass. Remember, that comes from the periodic table. So it'll be Na and O and H. So Na is 23, oxygen is 16, and H is 1. We add those three together and we get our molar mass of sodium hydroxide. Now, there's different ways that we can do this question. Personally, what I would do is I would use the following formula. I would use this formula over here. That tells me that concentration is equal to mass divided by molar mass multiplied by volume. If you look at the formula, it's mV, which is molar mass times volume. Okay, this is one way to do it. Then you substitute. So we're looking for concentration. My mass is 15. My baby M is mass in grams. Molar mass is 40. And volume, remember you must convert, is 0,3. If you do that, your answer is 1,25. Now remember, for concentration, your unit is mole per cubic decimeter. It's very, very important, grade 10s, 11s, or 12s, whoever's watching this, to learn the correct units, because you will get a mark for formula, substituting correctly, and answer with the correct units. You need to recognize your correct units. Another way to do this question is to use the following formula. C is equal to N over V, number of moles per unit volume. But if you decide to use this method, you will notice that I'm looking for C. I have volume. I'm looking for C, but I don't know N. I don't know number of moles. If that's the case and I want to use this formula, so I'm talking about this one over here, I need number of moles first. So I can also calculate number of moles using this formula over here. So this would be a two-part question, or a two-step or two-formula question. So in the place of mass, you would put 15. Molar mass is again 40. Then you have to calculate the answer for N, which is 0,375 mole. Then I use the second formula. So I'm looking for concentration, 0,375, and I divide that by volume. Remember, it must be converted, 0,3, and that's where I get the exact same answer, 1.25 moles per cubic decimeter. One thing that throws some of my grade 10s off, and even my grade 11s, is that they say that the solution is the 15 grams of NaOH is dissolved in 300 cubic centimeters of water. Now remember, when we're working out the molar mass, when you're working out the number of moles, it's only the solute that I care about, NaOH. That's why I only use NaOH to work out the molar mass, because it's only the moles of the solute that I care about. Remember, it's moles of solute per unit volume of the solvent, which is the water. So the fact that it's water doesn't actually matter, doesn't affect the calculation. That just impacts the volume. If you would like more videos where I go over concentration and these sorts of calculations, check out the links in the description box. 1.2 says we want the volume of 4.25 moles of nitrogen gas at STP. Now remember, as soon as you see STP and as soon as we're working with gases, we know we're going to use the following formula. N equals V over Vm. Now remember, at STP is standard temperature and pressure. Here is molar volume, Vm. At STP, it has a set value, 22.4. It'll always be 22.4 if the experiment or the reaction takes place at STP, which it does. We know this, 4.25, which is moles, which is N. 4.25. So in the place of N, I'm putting 4.25. In the place of V, I'm leaving it open because we're looking for volume. And then we solve for V. So you say 4.25 multiplied by 22.4, and I get 95,20 cubic decimeters. Remember, you should round off to at least 2 decimal places, and our unit for volume is cubic decimeters. Molar volume is measured in cubic decimeters. Therefore, your volume will also be in cubic decimeters. You get a mark over here for your formula, substitution, and your answer. And just by the way, over here, your marks would be either it's 4 marks. So either you can do 1 mark for both formulas, substitution, and the final answer. Or if you use the combined formula, then you get your marks for the formula. You get 2 marks for substitution, so top and bottom, and then 1 mark for your final answer. This question wants the number of hydrogen atoms in 4 moles of CH4, otherwise known as methane. Now, grade 10s, as soon as you see a question asking for number of, and they either say number of molecules, formula units, atoms, number of ions, number of particles, so number of, you know you need to use the following formula, where little n is number of moles, Na is Avogadro's number or Avogadro's constant, which is given on your formula sheet. It will always be this value. And big N is number of molecules or formula units. So big N is number of molecules. So what we're going to do is, in this question, they're giving me 4 moles. Remember, moles is N. So what they're doing is they're giving me N. I'm going to substitute 4 in the place of N. We're looking for number of molecules, and A is Avogadro's number, 6,02 times 10 to the power of 23. How you solve that is you say 4 multiplied by this number over here. I recommend using brackets when dealing with scientific notation, and you should get 2,408 times 10 to the 24. Now remember, what this is it is the number of CH4 molecules. This is very, very important. Big N gives me the number of molecules or compounds or formula units. But that's not what the question wanted. We wanted to know the number of hydrogen atoms. So I want you to think of it like this. In 1 molecule of CH4, so if I write CH4, this is what it looks like in reality, by the way. It's called methane. This is 1 molecule. This is 1 molecule. How many hydrogen atoms does 1 molecule of CH4 have? 1, 2, 3, 4. So 1 molecule has 4 hydrogen atoms. How many hydrogen atoms would 2 molecules therefore have? 2 molecules would therefore have 8 hydrogen atoms. So how many hydrogen atoms would this many number of molecules have? The number of H atoms would be that number of molecules, so 2,408 times 10 to the 24, and we would need to multiply it by 4. The reason we're multiplying it by 4 is because it says H4. In 1 molecule of CH4, there are 4 hydrogen atoms. So you need to multiply the number of molecules by the number of atoms within that molecule, and you should get 9,3632 times 10 to the 24 hydrogen atoms. If they wanted the number of carbon atoms, it would be that number. So again, the same number of molecules, but you would times it by 1 because there's 1 carbon atom in 1 molecule. I hope that makes sense. So this is 4 marks. You get it for formula, substitution, answer for molecules, and answer for final number of atoms. My next question wants me to calculate the molar mass of a gas and they give me moles, and they give me mass in grams. So again, what do you have and what do you want? We want molar mass, so we want big M. They give me 2 moles, that is N is 2 moles, and they give me mass of 20 grams. That's baby M is 20 grams. So I hope that this is nice and straightforward for you. What we're going to use is this formula, because we're looking for big M. We have baby M and we have N. So in the place of N, I put 2. In the place of baby M, I put 20. And in the place of big M, I leave it as big M because I'm looking for it. Now, if I'm solving for the variable and the variable is at the bottom of the fraction, what this means is that this variable, the unknown at the bottom of the fraction, must swap places with the thing on the other side of the equation. So big M is equal to 20 divided by 2. These two things swapped places. So big M is 10, and remember the unit for molar mass is grams per mole. The next question says, what is the percent by mass of oxygen in H2SO4? Now, the wording of this throws a lot of students off. Basically, what they're asking is for percentage composition, which we also did call percent by mass. Now, when working out a percentage, you know that you need a fraction. So we're going to have a numerator and a denominator, and we're going to times it by 100, and that will get me a percentage. Now, what do they want a percentage of? They want percent of oxygen. So what we're going to do is we're going to, at the top of the fraction, have the oxygen mass. At the bottom, we're going to have the total mass, and we're going to times it by 100 to get it to percentage. Why am I saying mass and mass? Because it says percent by mass of oxygen in H2SO4. So our goal here, what we need to do is we need to work out what is the mass of oxygen in this compound. And when I say mass, I mean the molar mass or the atomic mass numbers. So if you look at your periodic table, I know you know that oxygen has a molar mass of 16. However, in this compound, there's not just one oxygen. The compound is H2SO4. How many oxygens are there in this compound? There's 4 of them. So that means that in this compound, oxygen's mass is not just going to be 16. It's going to be 16 times 4, because in this compound, there's 4 oxygens. The total mass is going to be the molar mass of the whole compound, H2S and O4. So hydrogen's mass is 1, but there's 2 of them in this compound. Sulfur's mass is 32. There's only 1 of them in this compound. And oxygen, as we said, is 16, but there's 4 of them in this compound. That gives me the total molar mass of the compound is 98 grams per mole. That means at the bottom of the fraction, I'm going to have 98. At the top of the fraction, I have 16 times 4, which is 64 basically, because that is the mass of oxygen. So it's 64 divided by 98 times 100. Why times by 100? Because we're getting percent. And I've got 65,31%. There we go. If you want more videos on percent by mass or percentage composition, click the links above or in the description box below. My next question is on empirical formula and molecular formula. I do have a lot of videos on this, so again, if you'd like more videos on this, please check out the link in the description box below. I'll list all the different videos that I have and the links for them. But in this question, they say nicotine, which is a chemical compound, and they give me the molar mass, 162 grams per mole, and they give me the percentage composition. First question, determine the empirical formula. We learned in the previous videos in this playlist that in order to get empirical formula, I need percentage composition. So we are able to go from percentage composition to empirical formula using the steps I taught you, and that's what we'll do in 2.1. Then once we have the empirical formula, I can get from that to the molecular formula, and that is what I will do in question 2.2. So let's start with 2.1. So our first step when determining the empirical formula is that the percentage is given to me. I immediately convert that to mass because we assume 100 grams. So 74.07% of carbon means that I have 74.07 grams of carbon. 17.28% of nitrogen means that I have 17.28 grams of nitrogen, and then they give me the percentage of hydrogen, which means I know the grams of hydrogen. Step 1 is I need to convert all of these to moles. I'm going to be using the following formula. I only need to write it once, but I'm going to do it for all three. So what I do is I take 74,07 and I divide it by the molar mass of carbon. So if you look on your periodic table, carbon is over here. It's got a molar mass of 12. I divide it by 12. I do the same for nitrogen and hydrogen. For nitrogen, it's 17.28, that's the mass, divided by the molar mass. And now this is where a lot of students go wrong as well. The molar mass of nitrogen is 14. So that means I must divide it by 14. Same thing for hydrogen. The molar mass, it's 8.65, that's the mass. The molar mass for hydrogen is 1. I divided by 1. And a lot of students say, but ma'am, isn't nitrogen diatomic? Isn't hydrogen diatomic? So mustn't I multiply this by 2? No, we only do that if we are working out the molar mass of a diatomic element or diatomic molecule. But in this case, I'm trying to figure out how many nitrogen atoms are in this compound. So I just divided by 14 by one nitrogen atom. I just divided by 1 for one hydrogen atom. I don't multiply it by 2. I ignore the fact that it's diatomic basically. You get an answer for each of these. Now, when you get your answer, remember you're getting your answer in moles. You do not round off. So this is what my calculator gave me, 8.65. Over here, this is exactly what my calculator gave me, 6.1752. This one was a long answer. I kept at least 6 decimal places. Don't round off. Your next step is you take your answer for moles and you put it in a mole ratio. So you literally write 6.1752 in a ratio with that one, in a ratio with that one. So that is the ratio of carbon to nitrogen to hydrogen. Remember, we're looking for the simplest whole number ratio. So the best way to find that would be to divide each of these by the smallest. That is the rule. In this case, this is the smallest one. Unfortunately, it happens to be the longest one. We're going to divide all three of these by the same number, 1.2342857. What you get is the following. If I divide 6.1752 by that number, by the smallest number, I get 5,003 ... If I divide this by the smallest, you're dividing it by itself, you're going to get 1, and then you divide 8.65 by that smallest number, and you get 7,008. Now, please take note, this is close enough to 5 for me to round it down to 5. That is 1, and this is close enough to 7 for me to round it down to 7. Therefore, my empirical formula is the following. C5, N1, we just say N, we don't say N1, we just say N, and H7. There we go. That is the empirical formula. Remember, if you need more practice on how to get the empirical formula, check out the links below. But let's move on to getting the molecular formula. You need the empirical formula first in order to get the molecular formula. So how it works is you take your empirical formula, which is C5NH7, and from your empirical formula, you work out your empirical mass. Now, how do you work out your empirical mass? You basically work out the molar mass of this compound. So we start with carbon. There's 5 carbons, so 5 times. Remember, carbon has a atomic mass over here of 12. So it is 5 times 12 plus there's 1 nitrogen, and nitrogen has a mass of 14. So plus 14 or 1 times 14, it doesn't really matter. Plus hydrogen, there's 7 of them. And hydrogen has a mass of 1. So 1 times 7 or 7 times 1. So we get the empirical mass as being 81 grams per mole. Then what you do is you consider the molar mass given, 162. Once you have the molar mass and the empirical mass, so these two masses over here, 81 and 162, we can work out N. Remember, N is the molar mass divided by the empirical mass. So my molar mass is 162, my empirical mass is 81. That gives me a value of N of 2. In order to get from my empirical formula to my molecular formula, I need to multiply the empirical formula, so C5NH7, I multiply each of the little atoms, number of atoms, by 2. Therefore, my molecular formula is C10, because 5 times 2 is 10, N2H14. That is my molecular formula. In our next question, we have a balanced chemical equation. We know we're going to be doing stoichiometric calculations using mole ratios, things like that. So it says iron reacts with oxygen to form iron oxide, also known as rust. And they give me the following unbalanced equation. First things first, grade 10s, you have to make sure that an equation is balanced. You can never ever assume that it is unless they tell you that it's balanced. Here they say it's unbalanced. 3.1 tells me to balance it. So how I would do this is you need to assess the equation that you have over here. Over here I have 2 iron atoms. On this side I only have 1. So what you could think of doing is maybe putting a 2 here. This may not work, and I know this is not going to work, but I want to show you how you do trial and error. Now you might say, okay, cool, the ions are balanced, but the oxygens are not balanced. Look at this side. So we've got the left-hand side of the equation has 2 oxygens. The right-hand side of the equation over here has 3 oxygens. Those are unbalanced. So the best way that you can do this is think of the smallest number, both 2 and 3 can divide into, and I think of 6. So getting them basically to the lowest common multiple essentially. And if you do that, you know that I need to make this over here 6. So I put a 3 over here. That gives me 6 oxygens on this side. And to make this become 6, I need to put a 2 over here. Now, on the left-hand side of the equation, I have 6 oxygens. On the right-hand side of the equation, I have 2 times 3, also 6 oxygens. But look at my iron. My iron is now unbalanced. On the left side of the equation, I put a 2 over there. It's not going to be a 2. I'm going to have to change it. On the right-hand side of the equation, I have 2 times 2 ions. I have 4 ions. That means I'm going to have to put a 4 over here. So it's a 4 to 3 to 2 ratio. That is your final answer. And just wanted to mention something. So there must be a big 4 here, a 3, and a 2. What I sometimes notice is sometimes students might balance the equation and they might give it to me like this. Something like that. If you had to count up each of the atoms on either side of the equation, like for example iron, you have 8 over here and 8 over here, you have 12 oxygens over here, and 4 times 3, 12 oxygens over here. So you could say that's balanced, but you won't get all the marks for this balanced equation because 8 to 6 to 4, that's not the simplest ratio. And when we balance, it always must be in the simplest ratio. So you would divide all of them by 2 anyway. So you'd get 4 to 3 to 2, which is my answer. 4 to 3 to 2. That gets you both your marks. My next question is working with the balanced chemical equation. If 100 grams of iron, that is Fe, reacts with excess oxygen, excess means I have over enough for the equation or the reaction to happen, how much rust should be produced? So what we're looking for is the amount of rust or iron oxide that is produced. And I want you to give your answer in mass. So essentially we're looking for the mass of rust, which is iron oxide, this Fe2O3, and they give me 100 grams of iron. So I'm given the mass of iron. Your steps when doing an equation like this, working with a stoichiometric reaction, a calculation like this, is, first of all, your equation must be balanced, which it is. Step 2, convert the given information to moles. So I was given 100 grams of iron. I need to convert mass to moles. So I'm going to use the following formula, this one over here. When I convert to moles, mass is 100 and molar mass is the mass of Fe. Now this is where a lot of students go wrong. They want to multiply the molar mass of Fe, which is 56 over here. They want to multiply that by 4. But you never ever multiply by the big numbers here. You only multiply by the little numbers over here, the number of atoms, not the big numbers, the number of molecules, the little numbers. So it's just 1 iron, so it's just 56. And you may write that in decimal form, but if you do, remember, don't round off. We're not at the end of the question. I would just leave it as a fraction. If you want to write it as a decimal, leave it to at least 6 decimal places, more or less. But you can leave it as a fraction. So the simplified version of the fraction is 25 over 14 moles. Now take note, that is the amount of iron that is completely reacted. Remember, the goal of the question is to work out how much rust, this is rust, how much rust will be produced. And you should know from the previous videos in my playlist, when going from one thing in a chemical equation to something else, which we are doing, we're going from iron to iron oxide, we need to use a mole ratio. You always need to use a mole ratio when going from one thing to the other. So we're going from iron to iron oxide. Tell me what things are in your mole ratio. Tell me what you're going from to what you are working out. And then you write your mole ratio, and that comes from the balanced chemical equation. So 4 to 2. You may simplify that. That is a 2-to-1 ratio. Then what we already know is that 25 over 14, that is the number of moles of iron, Fe, that will be consumed or reacted. So under iron, in this column, under the mole ratio, we're going to put 25 over 14. Now we need to work out this over here. Basically what we're doing is we're saying, if we use up 25 over 14, which we are, we're going to use up all the iron, how much rust will be produced according to the mole ratio. Now, I don't mind how you do ratios, but I think of it like this. How do you get from 2 to 1? You must divide by 2. So then you're going to have to divide this fraction by 2. Another way to think of it, and this way will also always work, you're looking for this. This is my unknown. This is what you have. You divide on the side of your ratios times on the top. Divide side times top. So 25 over 14 divide by 2 times by 1. And I get the following. So that, I'm going to continue over here, is 25 over 28. Or if you wrote it as a decimal, 0.892857. And that's the moles of rust that will be produced. But remember, I want your final answer in mass. They say how much rust. Let's assume they want it in mass. So how do you convert from moles back to mass? You use this formula. But now remember, this N that you put in is the moles of rust. I'm going to put it in as a fraction, 25 over 28. The mass is what I'm looking for. And now the molar mass, that is the molar mass of Fe2O3. Okay, because this is the moles of Fe2O3. So the molar mass is of Fe2O3. Remember, we don't include the big number in front when working at the molar mass. So it's basically Fe2, so 56 times 2, plus, remember it's Fe2O3, plus 16 times 3. That gets me a molar mass of 160. And then your final step to calculate mass, you multiply 160 by my fraction, by my number of moles. And I get 142 point, round off to 2 decimals, 86 grams. So this is a lot of work. Where do you get your marks? You get your marks for formula and substitution over here, mole ratio, using it correctly, formula and substitution over here, and your final answer. 3.3 is saying if the actual mass of iron oxide is 130 grams, what is the percentage yield? In my percentage yield video, I showed you that percentage yield is equal to the actual, and it can be actual moles or actual mass, it doesn't matter. So in this case, we're doing actual mass over theoretical mass. And we multiply by 100 to get it into a percentage. Always remember, it's actual on the top, theoretical on the bottom. 80 at times 100. In this question, they tell me my actual mass is 130. You are most likely going to be given the actual mass. Sometimes not, but most of the time you are. The theoretical mass is always what we calculate using our stoichiometry. And we got that in the previous question here. Using our mole ratio in the balanced chemical equation, we worked out that we should produce 142.86 grams of rust. But in reality, we only produced 130, the actual yield. To work out percentage, you say actual divided by theoretical times 100, and you should get 90.998 so on percent. If you round that off to 2 decimals, it's 90, remember, round off there. So it's actually 91% is your percentage yield. There we go. So where do you get your marks? You get it for your substitution, multiplying by 100, and your final answer. The whole test is out of 32 marks, so give yourself a mark, total it, see what you got, comment down below. Let me know if you like doing videos like this. I'll do more tests with you in the future. Remember to subscribe. I'll see you very soon. Bye, everyone.